Hey, what is going on, guys? Welcome to Flash Tutorials, and this is the maze generator series, and we are almost done with the maze generator. If you didn't saw the last episode where I explained how the DFS or depth first search works, you probably want to check that out one more time, because that is the main logic that we're going to use in this episode. And what we're going to do is we're going to apply the DFS, depth first search, to make our mazes. And yeah, that's pretty much it. It's not going to be very big. So yeah, let's get started and open up the maze script. So I'm just going to open it up right here. Okay. So there are a couple of things I want to do before I go ahead, and that is we're gonna program our stuff today in the create maze function. So what we're gonna do is we're gonna go ahead and start with an if statement, and we're gonna go ahead and create some variables. Okay. Now these variables are not really that difficult. Okay, so I'm just gonna create a private variable. I'm gonna call it visited. Sorry. It is an integer, of course, and it is called visited cells. And this is basically a number of cells that has already been visited by the system. Okay, so we're just going to go ahead and compare it with the total number of cells. So it's going to be visited cells, and the total cells. I'm sorry. You're going to want to go ahead and cut this. You know what? I'm just going to go ahead and go. Visited cells should be smaller than total cells. Okay, so we're gonna go ahead and take this guy right here, which is the total cells. I'm gonna go ahead and cut it from the give me neighbor function, and we're gonna put it right over here, which is basically create cells function. So we have total number of cells saved and locked on this variable. Now what we're going to do is we're going to go ahead and program our system. So the first thing that we want is we want to check if the first wheel have been chosen or not. So what we're going to do is we're going to go ahead and create another if statement, and this if statement basically going to hold a variable or a boolean, basically, which is going to hold started building. Okay, so it is showing as red because the start building variable haven't been created yet. So we're gonna create that. So start building. We're gonna go ahead and create a private boolean, and this is started building. Default value is gonna be false. Okay. All right. Now what we're gonna do is we're gonna go ahead and what we're going to do is we're going to put it in an else if statement. So we're going to go ahead and go else. So we're basically checking if you have chosen the first if you have chosen the first cell or not. So we're basically going to go ahead and choose the first cell, which is basically going to enable us to start building the maze. So we're going to go ahead and go current cell, and the current cell equals, I'm going to go ahead and put random dot range. All right. Now this will gonna basically have two parameters. Now the first parameter is the minimum value, and the next parameter is basically the maximum value. So it's gonna go ahead and choose a random number in between them. So I'm just gonna go ahead and choose 0 to total number of cells. So basically, total cells right here. Okay. So if we're gonna give us a random value. And what we're gonna do is we're gonna make this cell visited. So we're gonna go current cell. So I'm gonna go cells. Right, current cell dot visited equals true. All right. Now we're gonna increment the visited value. So it's gonna be visited cells. We increment it. And yes, once we have chosen that, we're going to go ahead and tell the computer that we are ready to start building the maze. So it's going to be started building equals true. Okay. Now, once this has been called, what's going to happen is we're going to go ahead and call the started building function in the next time. But before we go ahead and do that, what we're going to do is we're going to go ahead and invoke this function. Now, what I'm going to do at the end of this episode is I'm going to put this if statement as a while loop. Now, I'm not doing it right now because if I put it in a while loop and the loop goes infinite, then we will be then the editor will be froze, will froze, and that we're gonna just crash down this tutorial. So I'm just gonna go ahead and put an invoke function right here, just for the testing purposes. I'm gonna change it. Okay. So we're gonna go ahead and go invoke, and we're gonna go ahead and invoke the function called create maze. Time, we're gonna go ahead and put 0.0. Sorry. Okay, so it will be called and it will work just fine. Now, in the started building function, what we want is we want to get the neighbor. So we're gonna go ahead and go give me neighbor. We're gonna go ahead and call and if we're gonna get us a neighbor. Now, before you go ahead and do that, we need one more variable. Okay, so we're gonna go at the top. We're gonna go ahead and create this as our private current integer current neighbor. All right. The default value, I'm just gonna assign it to 0, but you don't really have to do that because it is a random value when generated by the system. Okay. Now we're gonna get the neighbor, but our system cannot really give us a neighbor right now. So what we're gonna do is at the bottom of the give me neighbor function, you're gonna want to remove this debug.log method because this was just for the testing purposes. It has nothing to do with the main function. And what we're gonna do now is we're gonna go ahead and make this function to give us a random neighbor. All right, so this is not really that difficult. What we're going to do is we're going to go ahead and check if we have found a neighbor. So we're going to check if length is not equals to 0. Okay, so if the length is not equal to 0, we're going to go ahead and go integer. We go ahead and go the chosen one. The chosen one, and it is basically a variable. It doesn't mean anything. Okay, and we're gonna go ahead and select a random value. So we're gonna go random.range. I'm gonna select a random value in 0 to length. And if we found a random value, what we're gonna do is we're gonna go ahead and assign it to the neighbor. So we're gonna go current neighbor, and we're gonna set it equals to neighbors, and we're gonna go ahead and call this the chosen one. Okay, so now we have a new neighbor. Now what we're gonna do is we're gonna go ahead and we're gonna check if we didn't get any of these this statement. It means if we haven't found any of these neighbors which we haven't visited yet, we're gonna go over here and we're gonna back up into the pathway. Okay, so that's what we're gonna do. But before we go ahead and do that, what we're gonna do is we're gonna go ahead and create a list. Okay, so I'm gonna go over here. I'm gonna go private list, and this is gonna be a private list of integers. So I'm just gonna go integers. Okay, private list integers. Okay, I'm gonna call this list as last cell. So it's basically a cell stack. That's all it is. Okay, and I guess that's pretty much it. Okay, so this is not small. Okay, so you can't really use the list without importing the generic class. So I'm going to go ahead and go using system.collections. Generic right here, and it should be fine by now. Okay, so we have a list view now. Okay, now if you are familiar with the C#, you know that you already know how to access the the list view. Okay, so before I go ahead and do that, I want to create one last variable, and that is gonna hold where we are in the pathway while backing up. So we're gonna go private, and we're gonna go ahead and create an integer backing up. All right, backing up, and I'm gonna go ahead and put it sorry, I'm gonna put it as 0 default value. I'm gonna go down, and over here what we're gonna do is we're gonna check if backing up is greater than 0. Okay, so if it is greater than 0, we'll go ahead and do this. Okay, so we're gonna go current cell equals, I'm gonna go last cell, and we'll check if you're backing up. Okay, and we're gonna go ahead and go backing up. We're gonna decrement it while backing up. Okay, so if we're gonna go ahead and check what was the last cell and assign as the current cell. If it is still not gonna find any of the neighbors, it will gonna back up furthermore. Okay, so yeah, now we are done with the with this function, with the give me neighbor function, I guess. No, we have to do one more thing, but we'll talk about that later. Okay, so if you go back over here, we now have a neighbor when we go when we come here. Okay, so now what we're gonna do is we're gonna go ahead and check if that neighbor has been visited or not. Okay, so we're gonna go ahead and type cells, and we're gonna put current neighbor right here. So current neighbor dot visited equals false. And we're gonna also check if the current cell have been visited. So just to make it sure, so I'm just gonna go ahead and go and I'm gonna go ahead and check. I'm gonna copy this. I'm gonna go here. I'm gonna go ahead put current cell. I'm gonna put it right over here. I'm gonna set it to true. Okay. So we are checking if we haven't visited the neighbor and if we have visited the current cell. And if this condition returns us true, we're gonna go ahead and break the wall in between the neighbor and the main cell. So I'm gonna go ahead and go break. I'm gonna create a new function. I'm gonna call it break wall. Okay, so this will gonna basically remove the wall in between the current neighbor, the current cell and the neighbor. But since this here, this is not been created, this function has been not created yet, it's gonna give us an error. So I'm just gonna go ahead and create this function. I'm gonna call it break wall. All right. Now the error should be removed. Now we'll program the break wall function later. For now, what we're gonna do is we're gonna go ahead and continue with our create maze function. Now what we're gonna do is we're gonna go ahead and go cells. Cells. And we're gonna go current neighbor, and we're gonna turn this visited boolean to true. All right. So once it has been turned true, we're going to increment visited cells, of course, and we're going to add this value to the last cell pathway. So we're going to go ahead and go last cell dot add, and we're going to add the current cell as our value. So we're going to go current cell. Okay. Now what we're going to do is we're going to go ahead and go set the current cell equals to current neighbor. Okay. Now, what we're going to do is we're going to go ahead and check, is we're going to restore the backing up value if we found the neighbor. So what we're going to do is we're going to go if, and we're going to go last cell dot count. This is just a set so it doesn't give me any errors. So we're going to go ahead, if count is greater than 0, then go ahead and then go ahead and reset the backing up value. So we're going to go backing up equals last cell dot count -1. All right. So now this value has been reset, which is basically the top value of the cell stack. All right. Now we're going to program the break wall function. So we're going to go ahead and break the wall in between the current cell and the neighbor. Okay, so for now, the break wall function doesn't know how to break walls. So we're going to go ahead at the top, and what we have over here is a cell collapse. So if you go ahead and call the north wall as 1, and I'm just going to call it as 1, 2, 3, and 4. All right. So this is pretty easy. What we're going to do is we're going to go ahead and program our function. We're basically going to tell what direction is the neighbor cell actually is, and what wall do you have to break by supplying the function with these values. All right. So it is pretty easy. It's not that difficult. It's very damn easy. But here's what we're going to do. Okay. I'm sorry. What we're going to do is we're going to go ahead and create a private variable, and we're going to call private integer, and we're going to go ahead and call it wall to break. Sorry, and the default value is 0. Don't worry about it. Okay, we're going to go down, and we're going to check if. You know what? I'm not going to check if. I'm going to go ahead into the give me neighbor function. And what I'm going to do over here is I'm going to go ahead and create one last area variable. And it's going to be basically same as the neighbors, but it's going to basically hold the value for the walls. Okay, so I'm going to go ahead and go connecting wall. Okay, and it is also going to be having 4 elements. Top 4 elements. Okay, now what we're going to do is we're going to go ahead and select tell what wall is connecting to the cell. So I'm going to go ahead and go over here. It's giving me an error. Oh yeah, new integer. I'm sorry, didn't really tell about. Okay, so what we're going to do over here is going to go current. Sorry, connecting wall. And we're going to go ahead and put length over here. Alright, and what we're going to do is we're going to set this connecting wall equals to whatever the value of the west is. So if you go ahead over here, we are taking west as 3. Okay, so I'm going to go over here, I'm going to put 3 over here, and we're going to go ahead and copy this, and we're going to put it in every function. Now the east, and we are taking east as 2. So where are these? Okay, so east as 2. East, and then the north, we're taking north as we're taking north as 1 and then 4. Okay, so it's 1. And then we're taking south. This is south, by the way. Okay, south, and we are taking this as 4. Right? Now what we're going to do is we're going to go ahead and tell the system that what wall is it that we're going to break. Okay, so we're going to go connecting wall. Sorry, wall to break is equals to connecting wall, the chosen one. Alright, so now we have a wall to break. Now if you go back over here into the break wall function, I'm sorry, somebody just messaged me. It's probably you guys because my Facebook is open right now. Okay, now I love you all, by the way. Okay, now what we're gonna do is we're gonna go ahead and put it in a switch case statement, and that's how we gonna do it. Okay, so what we're gonna do is we're gonna go ahead and put it in a switch case statement. So I'm gonna go switch, and we're basically gonna supply the value which is wall to break, and we're gonna go ahead and put it right here. Now we're gonna put cases. So if in case it is 1, okay, in case it is 1, what you're gonna do is you're gonna destroy. Now you can go ahead and disable the game object if you want to use it in some other way, but I'm going to destroy the game object because I'm not going to use it in any way. So we're going to go ahead and destroy the wall. So I'm just going to go ahead and go destroy. I'm gonna go cells, and I'm gonna get the current cell, and because the case is 1, which means this is the north, so I'm gonna destroy the north game object. All right. Now what we're gonna do is we're gonna go ahead and break this statement so that we don't go any further. Okay. Now copy this. I'm gonna paste it 4 times. Okay. Now we're gonna go case 2, 3, and 4, and I go by the news iteration, so it says NE, so it's gonna be east. This is gonna be west, and this is south. Sorry, south. Okay. Now I guess we are done. But all we need to do is we need to go ahead and test it out. So I'm just gonna go over here. Okay, we are getting an error. What does it say? Object is not set to ref stance of an object. Last cell.add current cell. It's an error because we haven't instantiated the class yet. So I'm gonna go ahead into the create cells function right over here, and I'm gonna go ahead and instantiate it. So I'm just gonna go last cell equals new. I'm gonna go list, and the list type is basically an integer. I'm gonna go ahead and instantiate it. We're gonna clear the last cell basically, so it's gonna be clear, so we don't have any values, and we should be fine by now. So I'm just gonna go ahead and run it. There you go. If we go ahead and play it. Okay, so it is working fine, I guess. I mean, it is creating pretty smooth. Okay, so I'm just gonna go ahead and put it at 10 by 10. There you go. It's working damn fine. If you wanted to use the look of the maze being generated, but it is kind of slow. Okay, it will be slow if you are using invoke as your loop iteration. So if you are using invoke as a loop iteration, it's gonna look good of seeing that maze is being generated, but it is kind of slow. So I'm not gonna use invoke. What I'm gonna use is I'm gonna use a simple while loop, and because that's what I want. But if you want, you can use invoke and end this tutorial right now. I'm just going to go ahead and use the while loop. Okay, so instead of using if statement, I'm going to go ahead and use while. Okay, so this is the while loop, and when this while loop ends, our maze generation it has been completed. So I'm just going to go ahead and I'm going to call it finish right here. Okay, now what we're going to do is we're going to go ahead and go back right over here. Oh, sorry. I guess didn't set log. Okay, got log, so that we know that our maze has been completed. Okay, I'm gonna go back. Let's create a 30 by 30 maze. Okay, I'm gonna go ahead and click play. There you go. Beautiful maze. Okay, so that's it for now, guys. I guess you understand what I was doing right over here. Okay. And now what we're gonna do is we're gonna hide the current cell variable because I'm not gonna use it in any way for now, at least. I'm gonna go ahead and go, where does current cell right here. Okay, I'm gonna go ahead and make it private because I'm not gonna use it in any way. I guess that's pretty much it. So yeah, I'll see you all later. Let's test that one more time. Let's create a 50 by 50 maze, and of course it's gonna take a little bit of time. Alright, so let's just go back. Pretty damn fine, right? And this is all inside of the maze game object, so you can go ahead and handle it pretty damn fine. You can see right here. Okay, one more thing. No, nothing. It looks good, and it is. You can see there is no circular paths. There is no cell which are being which will lead you to its own path. So that's pretty much it. This is a maze that is using DFS. So we have been creating the square maze. Let's create a rectangle one. So I'm just going to go ahead and go 30 by 10. Let's create a 30 by 10. Okay, it is working damn fine. Let's do it one more time. One last time. Hey, what is going on, guys? I'm here to tell you that I have done something wrong in the second episode of the maze generator series. So I'm gonna go ahead and tell you what that error is, and I'm gonna tell you how to fix it. Now, keep in mind that this error does not affect your algorithm or your maze in any way. It's just a small code error that we were not supposed to do, but it actually happened by mistake. All right, so I'm gonna go ahead and show you what that error is and what it does. And what I'm going to do is I'm going to go ahead and make the cells class public, because we are going to test what the error is, and I'm going to comment out this create maze function. Now the error is in the create cells function. Now let me show you what the problem is. So I'm going to go ahead and create a maze of 2 by 2. I'm going to go ahead and click play. Okay, it's going to take a while. Okay, so the problem is over here. So if you go ahead and take a look at over here, so if you go ahead and take a look at the third element of the cells array, you're gonna notice that there is a problem, and that is according to our theory, the third element should be this cell, and if you take a look at the east wall, so according to the theory, the east wall should be this wall, but if you double click on it, you're gonna notice that it is this wall. Now this is an error, and it doesn't affect the algorithm in any way, because we are not supposed to touch the border walls. So this is just a simple problem. We're gonna fix it. It does not affect your maze generation in any way, but we will fix it. Okay. So the problem is that if you go back and take a look at it over here, so this is the create cells function, and what I did over here is I basically incremented the east-west process by 2, and you are not supposed to do that, because if you're incrementing a value by 2, you are skipping a wall, and that's what I did, that's what I did wrong over here. Okay, so what I'm going to do is, there's a very simple fix. What I'm going to do is I'm going to go ahead and move this function to the top, and I'm just going to increment it by 1. I'm going to copy this whole thing. Actually cut it out, and I'm going to remove this else statement. Now I'm going to leave the east-west process incrementation over here as it is. I'm going to go ahead and paste that function right over here. So we are basically going to check before we settle the east-west process for the east wall. We will just going to check. We're going to do a simple check, and if we are at the end of the exercise, we'll basically going to increment it by 1. Okay, now I'm going to save the scene, and I'm going to go ahead and check it out one last time. Okay, I'm going to go ahead and hit play, and I'm going to go onto this wall right here. I'm going to go ahead and click on east, and it works. Okay, now we're going to check for west, because if anything is wrong, it's going to happen to west as well. So west is working damn fine. Let's go and check for this guy right here. It works. Last one, west, it works. Okay, let's go ahead and check for these two as well. So east, west, okay, east, west. All right, so it is working damn fine. Now let's uncomment the create maze function right here. So I'm going to uncomment it. Go ahead and let it compile. I'm going to go back over here, and what I'm going to do is I'm going to go ahead and create a slightly big maze right here. I'm going to go ahead and click play, and it should generate a maze for me. Okay, so this doesn't give you any error. This error doesn't interfere with the algorithm in any way. It's just a small thing happened that we are not supposed to or intended to do. So that's pretty much it, guys. That's the wrap. So I'm gonna wrap up this tutorial series. That's all it is. I hope that you guys liked it, and if you're watching this, thanks for watching this series. I'll see you guys later, and I have a great content coming up for you guys. So yeah, stay with me, and let's create a big maze. Okay, so I'm just gonna go ahead and create a 30 by 30. Okay. you know, one more thing I can show you is if you go ahead into the prefab section, I'm gonna increment the length on the Y size by 2, and if I go back over to the maze generator and I increment the wall length to 2, you're gonna see I have a bigger maze now. Okay, if I go back right here, and you can see the size of the wall is working. Okay, so yeah, you can go ahead and play around with this. If you create any game using this maze generator, please go ahead and tell me that you used it. I would love to play it. I would love to try it out, even if it is premium or anything like that. I would love to try it out. And thank you guys for watching. I'll see you guys later. Until then, goodbye.